grab that little controller here. So this was really a grad student led project. And we have 3 faculty members that are here today that will be trying to present what the grad students did. It actually came out of a class that I very lightly oversaw in the spring of 2012. And a group of graduate students from across 4 colleges and 9 different departments participated. So this really emphasizes the interdisciplinary nature of this particular project. Zion Kloss, who is a PhD candidate in environmental science, he's the real genius behind this. He's the ringleader. He's the one who probably should be presenting. But he's somewhere in the Erie Canal as he's on this voyage to participate in climate communication up and down the Atlantic and into the Caribbean. So we'll be doing our best to try to present their work here today. So again, we're talking about a large number of graduate students that led this project. They basically came together as a class, identified some of the gaps. We'll get into those gaps here today. And then coordinated amongst themselves, lightly advised by their advisors, to set forth to provide a synthesis of climate indicators for the state of Idaho. Now, we have some idea about climate change, but one of the problems with global climate change is it's difficult to wrap our head around. It's a term that means different things to different people. For many, global climate change is simply too distant, it's too big, or it's a problem that won't impact them. And for this reason and many others, climate change is very low on the priority list typically when we have public opinion polls. Now, the data that we have, one of the hallmark indicators that we have for tracking climate over the past century and a half is global mean surface temperature. Now, what is that exactly? Hypothetically, it's a measure of temperature across the globe every meter, every second, and we average that and we get one number per year. And when we look at that, we see time series that look something like this, where we have 1880 over here, and this data goes up until 2014. And we see this signature of warming through time. And this is pretty consistent. There are a number of different groups globally that track temperature using different approaches. When we look at this, there's a little bit of a problem for a lot of people. Number one is that the overall change in global temperature that we're talking about here is on the order of maybe around 1.5 degrees Fahrenheit, 0.8 degrees Celsius. And that's a little bit challenging, I think, for people to deal with, because 2 days ago versus today, the temperature changed 10 degrees Celsius or 15 degrees Celsius. So 1 degree Celsius, that's a little bit difficult for people to get excited about. The other problem that people have, certain camps, I will say, is that they believe, for some reason, that the data behind that graph that I put together is fraught with error. How do we track global temperature? We don't have thermometers everywhere on the globe. We certainly didn't have them in 1880. And they have this idea that scientists are cooking the data. Now, mind you, if they were cooking the data and they all came up with the same results, it would be quite coincidental that they're using the same recipe. What if we don't believe thermometers? What if we don't believe that data? What else could we go to? What other observations do we have that suggest a changing climate? This is the crux of what we'll be talking about today, looking at climate indicators. And these are simply defined as observed data linked to climate, and they can span the spectrum from physical variables, ecological variables, and even variables that involve human dimensions. And the National Oceanic and Atmospheric Administration has synthesized a set of global climate indicators, which is shown in this figure here. So again, if we don't believe the records that show increases in temperature What about glaciers? What about snow cover? Sea level has risen through time. Sea ice has declined. All these things paint the picture of a warming planet. They're all telling us the same story. So these are all indicators globally. Now, we don't all live globally, hopefully. And so you might ask the question, what's happening on more regional scales? Well, there has been efforts put forth both nationally as well as individual states to look at climate indicators relevant to smaller jurisdictions. I was actually part of this one in California, and there have been similar efforts amongst our neighboring states to synthesize changes in climate impacts, and also to synthesize the projected changes in climate and what it might mean for the future environment. Oregon and Washington have both done this. Idaho has not. There's really a gap in Idaho for any sort of statewide assessment, either of the observed past or what's coming down the pipeline. And that leaves us in a somewhat vulnerable situation. If we know what's coming down the pipe, we can actually start preparing and create a more resilient society. The other problem is the perception of climate change. So the Yale Project on Climate Communication completed this study that was basically across the United States, and they asked a number of questions. One of the questions that I'm showing here is whether or not people believe that global warming is happening. And while a majority of America believes that global warming is happening, there's geographic variability built into that. And Idaho comes in ranked 42nd out of 50th in terms of answering this particular question. So we have a void in Idaho of climate synthesis, and there's also a perception that climate change is maybe not that important or maybe not even happening in the state. So this leads us to the motivation of the work that was conducted by these students. And basically there was two key points. One was to try to assemble observations of climate indicators for the state to fill this void, to at least show what has happened over the past century, using as much data as possible. And the second piece that the students set out to put together was to put together a framework for these indicator-focused assessments. Mind you that most of these indicators have typically only just went out and looked at the data. They haven't actually taken the time to ask what is important amongst the stakeholders. So they're trying to accomplish both goals, because if we provide indicators of things that no one cares about, maybe that has a low impact, versus providing things that people care about and having the data to show that. So this was a two-part study. There was a survey that was conducted amongst land managers and people involved in natural resources in the state of Idaho. And among the questions that were asked were, what climate impacts are you most concerned about in Idaho? And then secondly, what climate indicators, we gave them a list, are most relevant for your profession? Now mind you, these are people in natural resources, so you might expect some of their answers to also be slanted in that direction. And what came of that was this figure here, which is a little bit complicated, but we'll walk through things here. On the y-axis here is basically the results of the survey. It's a measure of importance, or the perception of importance amongst different climate indicators. So what ended up coming out in Idaho is that people were really concerned about water resources. So that makes sense. Water is the lifeblood for a lot of the things that drive our state. So they were concerned about stream flow, drought, snowpack. They were also concerned about things involving ecological disturbances, fire, and the productivity and viability of species. As we move from the left to the right on this diagram, we go from indicators that are pretty much directly related to climate, air temperature and precipitation. You can't get, that's pretty much climate by itself. As we move further to the right, we start dealing with indicators that are influenced by climate, but also influenced by other things. So this moves us out here into a lot of the ecological indicators. So we looked at all of these indicators that were out there. And the challenge was to find out how we could synthesize these for the state of Idaho. You can't just take a record from the central part of the state and call that representative. Certainly in a state like Idaho, where we have complex topography, climate, and impacts as well. So the students went out and they looked for data. They all had a separate indicator. They went out and looked for data, and they looked for a few things in their search. One, they wanted these indicators, these data sets, to be sufficiently long. You can't just use 5 years and call it an indicator. So 30 years long, they wanted it to be as widespread as possible. So hopefully not just one station, as many as possible. And then finally, they wanted these data to be publicly available so that there's a certain amount of reproducibility. So I'm going to present a couple of these indicators and then hand it off to my colleagues here. The first one is temperature. So I showed you earlier a graph of global mean temperature by year. This is one for the state of Idaho. It starts in 1895 and up to present. And I'm not showing you here the calendar year, but I'm showing you here the 12 months ending in August. That's just so that we can look at 2015, since we all know it's been a somewhat unusual year here. Like the global temperature, we have seen an increase over the last century or so. It's pretty much on par with what we've seen globally. The one difference is that we see a lot more year-to-year variability, and that's just due to the fact is as we refine our spatial extent of any sort of indicator, especially climate, you get a lot more noise from natural variability. But one thing that's very clear is if you look at the last 10 to 20 years, there's really no other sort of period like that over the historical record. So we've entered a new sort of climate, at least over the historical record. And 2015 has certainly been warm. 1934 is the warmest year on record. We'll see what the next few months have in store for us if we challenge that at all. So we conclude that temperatures have increased in Idaho as they've increased in the United States, as they've increased globally. Now, the increase in temperature in Idaho is about 2 degrees Fahrenheit. So I don't think that's a make or break for people if they want to decide if they're going to wear shorts or pants, right? That's not such a big thing. So one thing that we wanted to look at was the length of the freeze-freeze season. This is simply defined as the number of days between your last spring freeze, the last day in spring when your temperatures get below 32 Fahrenheit, and the first day in autumn when your temperatures get below 32 Fahrenheit. So we usually play this beat the clock game in Moscow when growing tomatoes, but not this year. Okay, we're way ahead of schedule. And tracking the data from a number of stations, primarily stations at lower elevations. We wanted to get this indicator was really geared towards agriculture. What we see is, again, a lot of variability through time, but clearly we see the last 10 to 20 years being very much unlike the previous period. We really have sort of gotten rid of a lot of these years with below normal length of freeze-freeze seasons. And among the things that we also asked the study participants was for them to just provide comments. And interestingly enough, we got a comment on gardening. And so this comment here basically is saying that this person has seen an increase in the growing season, and that's been beneficial from the perspective of growing their own backyard garden, but there also might be downsides with that, particularly with respect to some of the ecological facets here. Before I hand it over to Tim Link, I'll show you briefly what precipitation has done in the state. Water resources, again, is one of the primary concerns in our survey. In terms of precipitation, we see a lot of year-to-year variability. We don't see any really long-term trend. We haven't seen the region get wetter or drier. We see periods, though, where it has been quite dry in the 20s and 30s, and then other periods like in the 70s and earlier half of the 1980s where it's been wetter than normal. So a lot of ups and downs, but no long-term trends. So we'll hand it over to Tim here.
And so, as we mentioned in the introduction, I'm Tim Link. Obviously, I'm not Penny Morgan. Penny will be next. But anyway, so what I'm going to do is to cover the snow and flow story out there. And so just, again, this is something that I think all of us are very aware of, is that the hydrology in the Pacific Northwest, and particularly this part of the world, is strongly snow dominated. And this is, again, another quote from one of the survey members that said that I'm most concerned about climate change's effect on water in Idaho and our ability to continue irrigated agriculture. And if you recall on that diagram that John showed at the beginning, in terms of what folks were most interested in, or what people saw as some of the big issues, it was water flow availability, drought, snow. So this is just the change in snow stations in Idaho in the 20th century. And there's really 2 months that I have shown here. This is what we call snow water equivalent. And what that is that's if you have a snowpack and you were to melt all of that snow, it would be the water that results from that snow. Because if you think about it, snow is actually mostly air. And so, for example, 25% is a typical sort of snowpack water content for snow. So if you have, say, a meter of snow and you were to melt all of that, you might have 25 centimeters. So this is based on the water actually in the snowpack. So red dots here represent decreases. The larger the circle, the larger the decrease. And likewise, blue represents increases. So we have here, these are based on automated measurements from SNOTEL sites, which are they're basically a large pillow that's filled with antifreeze that effectively just weighs the amount of water in the snowpack. So what we have here for January, it's kind of over the map. We have some sites that are increasing and some are decreasing. But of course, keep in mind that it's cold in January, right? So there are not a whole lot of places that are picking up midwinter rain. But if we look at April 1st, what you see here is west-wide. Most of the stations end up show declines in the snowpack. There are a few isolated cases that show increases. And a lot of those places that tend to show increases are places that are quite high in elevation where you're not crossing that freeze thaw threshold. So that's the snow story. And then this is just the trend in April 1st snow water equivalent from 26 sites throughout the state. And again, the average here is based on the 1970 to 2010 period. And what you can see here is really a lot of variability year to year because there's a lot of other things besides there's a lot of things that control how much snow gets deposited on the ground. But again, just to reemphasize what John was showing in his previous slides, you can see that in this latter half of the 20th century, we see many more years that have much lower snow water equivalent. And so that, of course, is a concern from the water resource and the agricultural irrigation perspective. So what I want to do here, and I think, is this embedded, John, do you know? Oh, okay. So what we have here, this is a flyover, and we're kind of staying away from future projections, but this is just, I think, something which would be useful just to get a better picture in terms of where we stand right now in terms of snow versus rain in the wintertime and how things are changing. So what the red areas show are areas that have significant quantities of rain in the midwinter, okay? And once we get this up, we have a nice little video. And this was actually used in the workshops that John had mentioned and that really motivated this whole piece. So this is a fly-through. And let's see, I may need to click. So what we're going to do is we're going to fly through a series of regions, starting with the Bitterroot Valley. And again, what we have here is the red areas are places which, again, during the winter months, which are defined as December, January, February, experience about 20% rain, roughly. And so you can see it's a lot of the Bitterroot Valley. And now what we're going to do is we're going to fast forward to the mid-century. And it just takes a little while for the animation to kind of kick in. But the point is just to try to visualize how much of the landscape is going to be impacted by changes in the midwinter rain to snow regime. So that's just a nice picture of the Bitterroot Valley. And next, I think we're going to zoom to the Grangeville area. We'll see. This thing flies by itself. Yep, there we go, Grangeville. And so again, this would be for what we like to refer to as the recent past period. And so again, these are the areas that will pick up rain in the midwinter. And then areas that are transitioning by the middle part of the century, we'll see here shortly. And so again, the point of these animations is just to try to get a picture of how much of the land area will be impacted in this particular region by the changing rain to snow regime in the midwinter. The next piece we're going to switch to is the McCall area, just because, again, we figure a lot of people are quite familiar with the McCall Payette Lake area. And so we'll just do a little swing around to McCall. And you can see Cascade Lake, Cascade in the lower part of the diagram. And this is really a key thing, because we were talking with a lot of managers in McCall, and they said, well, really, we don't think we're seeing effects of climate change. And we started, actually a bunch of us, Penny was there, we were brainstorming one night and said, well, we think McCall is really too high. They're not seeing it yet. And so this is going to be then basically what the future holds. So again, that just provides a nice visual of what we're expecting. And in fact, the point is that these are not changes that are not just projected to occur, but they are occurring and they have occurred in a lot of areas. Okay, I'm going to jump back out of here. No, I've got two open. Which one is it? Okay. So that was the snow story. And again, the key point of that last little animation was to look at the effect of the changing midwinter rain versus snow regime. So the next one, though, is how does this matter for stream flow? And there's really three main things that we're concerned about with stream flow, and that is the timing of stream flow. So when does the water run off? What is the amount of stream flow? So what is the quantity available? And then another piece that I'm not really going to hit on is stream temperature. Are streams and river systems warming up? And that's a much trickier problem. So first of all, in stream flow timing, and I'll just briefly walk through what this particular plot shows. So we're looking back to, I believe, about 1950 to 2000, and what the bars represent is the day of what we call the center of timing of stream flow. And so that's actually a pretty easy concept. But what it is it's the date that half of the water has moved out of a watershed. Okay, so if you add up the entire volume of water that comes out of a watershed, when does half of it come out? And so what we see for a lot of these areas is that on average, again, based on this 1970 to 2000 period, is that most of the water comes out of the watershed by around day 132 or so in the year. But what we've seen is in the past that flow is coming out later, and what it's been doing more recently is coming out of the watershed earlier. And the reason for that is really twofold. One is because there is more rain in the midwinter period versus snow, and then the other, of course, is snowpack is melting earlier. So if we look at the major river basins throughout Idaho, and it varies quite a bit by basin because some are very high and cold, others are lower down and are warmer. But what we see for the major rivers in Idaho is that we see the timing of peak flow being about 11 days earlier than it was in the 1950s. Okay, so water is moving out of the system about 2 weeks earlier. And that has some real implications for aquatic species, for irrigated agriculture, for water resource use. Sort of funny numbers that are wrapped around. Anyway, so stream flow volume. This is the other question then is what is the amount of stream flow which is coming out of the system? And again, this is based on, you don't have to worry about the actual volume, but this is statewide. What we have here, as you can see, this is the total amount of stream flow around 1950 was higher and again is on the decline. Now, some of that is due to precipitation changes, and I don't know if anybody picked up on the slide that John just showed showing the precipitation trends. But there actually is a slight drying trend from the 1950s to the present. It's actually pretty flat if you go back to the early part of the century. But from the mid-century on, there actually is a slight drying trend in precipitation. It's also due to, we think, increases in evapotranspiration, and it may also be due to changes in deposition in high mountains. So overall, just to sum up, there's a decrease in the past 50 years, although again, there's a lot of variability year to year. So I'm going to pass this over to Penny now, who's going to talk about fire and the ecological impacts.
So fire is one of those things that the survey recipients wanted to hear about. And certainly it's been quite a year, hasn't it? For fire and smoke. Hopefully that'll work. And when we look back through time, I don't have on this figure this year, but here's 1910. And so we had a lot of area burn in 1910. We had a lot of area burn in some years early and some late. And lots of people are asking, what about these recent years? Are we seeing, we've had a lot of large fires. We had a lot of large fires in Idaho. Enough so that Rocky Barker recently said that Idaho is the wildfire capital of and only Alaska, which is a lot larger, has more area burned if you look back through time. So why might this be? And one useful thing is to look at these existing data. So this is, I'll have a little bit about projections into the future, but this is from existing data. And so here is basically the take-home messages that the fire season has gotten 32 days longer since 1984 across Idaho. When you account for these data were built from what's the earliest, so this is the from the first day of the year to the last day of the year. What's the earliest any fire was detected, a large fire? A little bit earlier, but the last fire any one out is a little later, and so the difference between these two lines is now 32 days longer than it was in 1984. That's based on satellite mapping of fires. And for some of us, we see, well, I go out and look at fires, but for lots of people, it's they're wondering, well, what's going on with Smokey? And I can tell you that Smokey's going to get more tired, particularly when you see the signs that where he's pointing from low to either to high or extreme. So this map over there on the left is currently how many high fire danger years do we have. My arm's already getting tired. And it's going to get more so because across much of Idaho, we're going to see a doubling of the number of years that Smokey is pointing to high or extreme. In Grangeville, for instance, 11 years now, 22 years, 11 days now, 22 in the future. And this matters to people. This quote is about tourism, but it matters. People who are interested in recreation, but people who are interested in logging, people interested in fishing, it all matters. So then, and Smokey definitely represents weather and drought and temperature that's conducive to fires. So it's saying we're likely to have large fires, as we've had in the past, well into the future. And what about other aspects? So our survey participants asked us about, asked the students, I say us. I was less involved, shall we say, than they were. But what about lilacs? How many are seeing earlier lilacs blooming? Yeah. It turns out if you run these numbers up here, so this is, I don't know if you noticed that the red lines are departure from normal. We're just taking average over that time period. Blue lines are above, red are below. So it would say here that we have more days where lilacs are blooming as much as 10 or 20 days. This one is more than 20 days earlier in some years. And indeed, it's 8 days earlier per decade. And this is based on citizen science, which is citizens taking notes and keeping track and recording those data and sharing them. This is data on salmon. This is actually Redfish Lake, but the data are from Lower Granite Dam, and it's a count of how many salmon arrived. So it's just their count, and it's pretty highly variable, and so no significant trend there, but bluebirds are sure noticing. They are nesting earlier. So this mountain bluebirds over here, this is again citizen scientists who were recording through time. And then what our students did was compare that to temperature. In this case, most observations were from around Rock Dam, and so that's where they got the temperature data. And they said that they found, like, if you take this line, which is the median, or the earliest any bird was found to be setting their nest, that 3 or 4 days earlier, just in this time period of the last 30 years. So that's the last of the data slides. What's next? You know, the students set out to do something that was of use to the people of Idaho, and this is part of their outreach. So is the website. It's about to go live to make all these data publicly available. And Kenton, I'm sure we could send out a link maybe through them. Sure. And so there'll be press releases and news stories, I hope, and they've already written, the students thought ahead and said, well, let's make sure that the things we're trying to communicate are clear. Good graphics and straightforward text. People ask about climate change, and certainly we have a lot of trends going on now that we presented over the last 30 years that are really consistent with some of the trends that are projected to happen in the future. And I think it's really evident, it's rapid, and it's going to have a lot of impact. We need to be thinking about that. But is it all gloom and doom? Many of you know me, I'm a hopeless optimist. And so I see those rays of sunshine. That's what I get excited about. And part of it in the fire world, I see communities coming together, people who are otherwise at each other's throats, who are coming together and saying, let's figure out how we're going to make our community safer and create jobs. I see lots of hope as well in that the systems, we have some time. They're changing and they're changing fast, but we still have some time to help with adaptation and mitigation. And most of all, I'm excited about the future. My daughter's here in the room, and these students are really amazing and are already prepared and active in fostering the conversations we all need to have about the implications of what climate changes we're already seeing going on in Idaho and what may be held for the future. So there's Zion, the fearless ringleader in the middle, but there were 18 students, and this was initiated by them and led by them. And they are, we wouldn't be here without them. So with that, I just want to say thanks to them and thanks to all of you for coming, and open it up for questions. So maybe Tim and John, you could come up here as well. Hand it back and forth, I guess. Questions? Yeah, Adam.
So, I may have not heard you, or I read things differently because of my disciplinary background, but your title has social perception in it, and I didn't get that. So can you tell me that part of the study, or re-emphasize it if I missed it?
You want to talk about it or what?
Yeah. So that was part of the survey that was conducted, and the survey wasn't conducted to the populace of the state, so it was targeted to natural resource managers, and we asked them, what things were they concerned about, what sort of climate-related metrics do they pay attention to as part of their job. So that was the extent of that sort of social engagement, trying to figure out what was an important indicator versus what was less important. It would be interesting to consider a sort of a broader base, so moving beyond just the natural resource managers, because I think that probably if we were to get information from more people in the state, that might look quite different.
I think that the students also learned a lot about communicating clearly. So trying to figure out how to present complicated data in a way that were reasonably accessible. Were they successful? We'll find out through time, I think. Nancy?
When you presented your list of possible indicators of concern to the natural resource managers, did you have open-ended question opportunities too? And if so, were there any surprises along the way? Did people express concerns or optimism, things that you hadn't anticipated as researchers?
This is where we need. Too bad we don't have the students here with us. I don't think any of us up here looked at the survey data specifically. It was open-ended to the perspective of we asked for their comments, and I don't know if we asked them to fill in the blank in terms of what additional indicators. That's an interesting idea, though, so I'm sure that they would think of other things that the group didn't think about. So if we had to redo this, I think that would be a great idea.
One of the challenges, I think, is that people and natural resources feel like they should be doing something. In fact, if they work for the Forest Service, they are required to be doing something about climate change. And lots of times they're looking at global data, and they're trying to decide, you know, the issue is a global one, but how do I act locally? And there are a lot of barriers to action. And I think none of those were, that wasn't primarily the focus of this project, but of an ancillary one. And the barriers were, in most cases, things that we would expect, and yet frustrating.
What barriers?
Some of it was a lack of, well, what does it mean locally? And do I have enough understanding to be able to start planting differently, plant species differently? Yeah, and most of the kinds of things that the Forest Service people that we surveyed as part of this other project said that, well, I'm going to use some of the kinds of tools that I'm familiar with. In the back seat.
I think questions for all of you today on one of the front pages of either Lewis or Daily News, and then I did some checking, it also showed up in newspapers throughout the country, is a headline, lowest snowpack in the Sierras in 500 years. Can you comment on the effectiveness or ineffectiveness of that? Or what it actually means, Tim?
Yeah, I can do a little bit. I mean, that's the issue that California, of course, as a lot of folks know, they've been facing a drought, which I can't remember exactly how many years it's been going on, but 5, 6, 7, 8, I think, at this point. And the thing about California, we actually did a nice little back of the envelope analysis. Actually, John did the bulk of it, was to figure out, at least get an estimate of the annual amount of precipitation coming into different areas west-wide, how much of that actually came as snowpack. And the one area that really lit up in that map that John put together, again, this was sort of a one-off, it's kind of the digital equivalent of a cocktail napkin kind of thing almost, is that California and the Sierra Nevada just lit up as like 90%, I think it was, roughly, in terms of how much of their precipitation came as snow. And so that snowpack is extremely important in California because that is what replenishes the aquifers, the stream systems, the reservoirs, et cetera. And so without that snow, I mean, they may get rain instead of snow, but the snow is a really important part of that system. And so California is also, as a side note, are investing a tremendous amount of resources in trying to map and understand where the snowpack is and how much they have every year. And not to go off too much on a tangent, but some of the things that they're doing, for example, is they're doing airborne LiDAR flights now over a number of basins in California every 2 weeks, where they actually, effectively the way it works is it's like shooting a laser pointer at the ground and then looking at how much snow is there versus what the ground height is without snow on the ground to basically track the snow depth and then convert that to water equivalent. And so they're trying to really optimize and understand exactly where the water resource is out there. So the bottom line is that yes, it's extremely worrisome because of the fact that snow is such an important resource in California.
But the message that it's a measure over 500 years.
Oh, right, that it was.
So how effective or ineffective is that? I'm just trying to play on your point here about what people pay attention to and what they turn off.
Mm-hmm.
And where did that number come from, Tim? 500 years.
I don't know.
Yeah.
Do you know, John? John's done a lot of work in California.
Yeah, so they basically had 2 sets of tree rings. One set of tree rings that was really good at tracking precipitation through time. And then another set of tree rings which was basically near tree line that was really good at tracking temperature through time. And so using this reconstruction approach, they paired the two and had about 500 years of data to look at. I think the one thing that is interesting about sort of these studies that combine observed data with proxy data is to be able to extend some of these indicators back. So if we have indicators only for 30 years, you could say, is that a trend? That's only 30 years, right? So as we get longer time series, then we can better contextualize the changes that we have seen. And so 500 years, that's a pretty long time. And similar studies have looked at drought, the current drought in California, and have basically put it up as the drought of the millennium.
I had a question about the salmon slide. That figure, is that when the first sockeye crosses the dam, or is it when a majority, half the population measured across the dam, or how is that?
Actually, I'm not sure.
Is median.
Median?
Mhm.
Okay, thank you.
Yes, it's a,
Median count. And there were some gray bars where there's lack of data. Go ahead, Tim.
oh no,
Do you have something else to add? Does that answer your question?
Yeah, because I know like salmon, I'm not sure about sockeye, but Chinook are highly influenced by the temperature of water, so you would think the temperature would be highly correlated with the air temperature, stream temperature, and the salmon move based upon those temperature changes. So I was just wondering.
They do, and there's lots of other things that affect the count of salmon. So besides, Lower Granite is actually just outside of Idaho, right? And that's a lot of water draining into there, and so, yeah, I think there's temperature changes that the salmon would be sensitive to in some parts of those watersheds that kind of gets swamped when it's the count over Lower Granite, near Idaho.
yeah, I was just gonna add one point as well, because I did briefly mention stream temperature, but didn't really go into that. And that, the stream temperature signal is actually quite messy. And what I mean by that is that there was really no trend that was detected in temperature, and that's because stream temperature is dependent on a whole host of things, including air temperature, solar radiation hitting stream systems, the amount of groundwater inflow, the timing of when snow comes off. So there's a whole bunch of controllers on stream temperature that go beyond climate and include a whole host of geologic factors. So that was a non-detectable trend for stream temperature.
The salmon also were so variable, those counts, that there was not a detectable trend.
One indicator that a certain segment of Idaho's population might relate to would be length of ski season at certain popular ski resorts. Has anybody looked at that over time? And is that something that might help with calling public attention to the results of the report?
Yeah, that's a great question, and that was one of the data points that students were looking for. They tried contacting a number of resorts and were unable to get data out. But something like that would be great. There were a couple other indicators that we just couldn't get ample data on. So that's somewhat of a limitation, but that would be a great one.
Yeah, Sun Valley would probably the only one that would have data going back 75 years, but some of the North Idaho resorts probably you'd be able to reconstruct from newspaper accounts of opening day, closing day, and
That's true, yeah.
how long they ran. And just anecdotally, I would assume that we're skiing far fewer days than we were 2 decades ago.
Any other questions?
I'm just curious, this is beautiful, you've done a great job, but all of you are professionals in this area. I wonder if you are able to project, knowing what we know about the climate modeling, as to what the next 25, 30 years might show. That's really good hardcore historical data, but I'd like you to project the future.
Mm-hmm. Only 25 years?
Oh, okay.
Well, so I mean, there's some interesting things with respect to using information from climate models and how far out into the future you'd like to use them. So if I wanted to know what was going to happen next year, I wouldn't use the climate models, right? As we get out to 10 to 20 years, there's actually a lot of natural variability that we have this climate change signal, which is going to continually allow for temperatures to warm, et cetera. There is some point at which the signal of climate change emerges from the background variability. Some people say that we're there already, and from some of the graphs that I think I showed, that looks to be the case. But there is a certain amount of uncertainty for these near-term climate projections. There's actually a whole set of new research questions out there that are using climate simulations that incorporate current ocean temperatures, since that's one of the ways in which climate memory is entrained. So that's actually a neat field of research that's ongoing, and the hope is to be able to have climate projections that are more accurate for the near term, next 20 years or so. And then beyond that, we probably have more confidence in terms of the overall projections but it's sort of a difference between thinking about changes in climate versus shorter time scales. You're contending with variability and maybe getting into the weather sort of segment.
But we're better at temperature than we are at precip, right?
Yeah, I mean, the precipitation signal I don't think will emerge. It doesn't emerge for Idaho. There's no real significant increase or decrease in precipitation.
I'll go out on a limb and say we're gonna have more large fires. That's we've had a lot of large fires in the past. So is that really going out on a limb in terms of the future? Not necessarily, but quite a few of the solid science projections are for 2 to 5 times as much area burned in our region as in the recent decades. Won't be the same everywhere. Snow?
Yeah, I mean, I can comment on that. I mean, that's another one of those variables which is very closely linked to climate is the snow and the midwinter snow, or the midwinter rain versus snow mix. That's again something which I think is pretty clear, is that the snow season will be declining and the peak snowpack will continue to decline. That's really quite clear cut, I'd say.
But with more impact in the shoulder seasons?
Exactly, yeah, more impact in the shoulder seasons, and so meaning by that is essentially having the length of the snow season decline. The way I kind of envision is it's sort of like if you think about a curve that's kind of a mountain. If that whole thing kind of shrinks down, that's what's happening, is that the peak snowpack is declining, and then on the shoulder seasons, your fall and spring, you're having snows arrive later and then stop earlier.
And it's the other thing it's all connected, right? So if it's warmer and drier, and we have more fire, and we have less water in the streams, and the fish are going to be struggling because they have probably a little bit warmer in the water where they live. And so it can create a perfect storm in some situations where we have multiple things happening at the same time. But I think the annual variability is something to pay attention to, just to realize that we're going to have variability. Does that mean we're not having climate variability or not having climate change? Not necessarily.
John, in your opening remarks, you said something about resiliency and preparedness.
Mm-hmm.
So with that in mind, do you intend to target the recipients of this? With Idaho rates number 42 out of 50 in terms of buying into this idea that climate change is happening. Are there particular target groups you want to talk to, or do you anticipate that the market forces will deliver the right seeds for a warming climate, or that recreational uses will just evolve because of how much snow there is or when the cycling season starts?
I think the reason that we try to conduct these scientific studies involving climate change is to identify what some of the risks are going forward. And by doing that, we can identify how we might be able to adapt. So this year has been really interesting. It's basically the year where we had a snow drought followed by fire. And we've seen impacts to a lot of the things that people care about in the state. We haven't been able to hike on Moscow Mountain all summer long. I think we're going to learn a lot from years like this in terms of adaptation. This is sort of like a stress test for climate change, getting us prepared. And it might be that it takes years like this where we see big climate impacts to get some of these communities to start thinking about, well, what if we start seeing this more often? What can we do to create a more resilient society?
So you have your mailing list in mind for this report yet?
Some of the students that are actually working on the outreach do have some people in mind. I'm sure it could be added to.
For me, there was a really aha moment. And it's like, wait a minute. I thought climate change was something that was going to happen. And I think this really helps people realize that there's a lot of change going on in ways that really matters now, and understanding that, and it's actually based on the data. I think it won't necessarily be persuasive to a climate change denier, but I think it opens people's eyes. It certainly opened mine.
So I'm from southern Idaho, and potatoes are a big commodity down there for agriculture. And do you know if anyone in the state or yourself, are you guys working on looking at risks to those kind of crops, like potatoes or grain?
I mean, University of Idaho is involved in a large project to look at the impact of climate change on dryland farming, specifically wheat. But it's primarily focused on sort of the Washington, Oregon, Idaho, not necessarily so much in southern Idaho, but some of the things that we're learning can be applied in southern Idaho. I don't know about the potato side of things, though.
We hope to have other climate change researchers at the University of Idaho on this program next spring, and maybe it's time to have Sanford and his team back for the REACH project to talk about those impacts on agriculture. I hope you'll come back next week for Gerald Logs' presentation on law in the landscape and landscape in the law. But let's thank first our team of graduate students on the screen, as well as their 3 faculty advisors for their expertise.